All right, welcome back, ladies and gentlemen. I'm going to get my face off here because we're going to have a lot going on screen, so you don't need to stare at me this time around. You're welcome. But we're going to talk about how to actually solve these systems using the matrix method. So I have over on the right here, desmos.com/matrix open. That's the website we're going to use. It's just an extension of Desmos. I've got a link right to it in the homework assignment as always, so you should be able to find it pretty easily. Looking at 6x plus y equals negative 39 and 3x plus 2y equals negative 15, we're going to set up our matrix just like we talked about in the previous examples. We're going to make that coefficient matrix. Okay, so if we call this matrix A, 6 goes here, 1 for the y, right, because there's nothing in front of it, so it's a 1, and then negative 39, 3, 2, negative 15. Okay, that's the matrix we're going to work with. Now, to do anything with this, though, we need to type this all into Desmos, and that's where this other window comes in. So what we're going to do is we're going to click New Matrix, and it's going to default to Matrix A, which is perfect. It doesn't really matter, but A is good. So we need to make it a 2 by 3 matrix, and right now you can see it's 2 rows, 2 columns. I need another column, so excuse that, okay? And now we have 2 rows, 3 columns, okay? Then we just type in exactly what we would have written in, right? So what we have written on the other slide here. So 6 and 1 and negative 39 for the first row. Do the same thing for the second row. 3, 2, and negative 15, okay? Now I'm clicking it in with my arrow so you can follow along, but obviously you can use your keyboard to type this stuff in as well. It's kind of 6 and 1/2 dozen of the other. It's all the same. Once we've got it in, click the enter button, and that now saves it, and now it knows what matrix A is. And then I mentioned in the previous video, we need to do the reduced row echelon form, RREF, of that matrix. So we just click the RREF button of A, and it's done. Desmos is so cool if you're into this kind of thing, which, you know, I am. But right there, okay? 1, 0, negative 7, 0, 1, 3. That lets me know these are my answers right here. 1x equals negative 7, 1y equals 3. So we write that as an ordered pair, and that's our final answer. And this is legit what I need to see. Your homework, when you're writing it out, obviously you'll have the equation written there for you, or you'll have to rewrite it if you're working on line paper. You have to write the system as you would type it into the calculator, and then you just give me the answer, okay? I'm not even going to make you write this matrix down, although if you want to, that'd be more thorough, but as long as I see you write the coefficient matrix and get the correct ordered pair, I'm a happy math teacher. I just gave thumbs up and you can't see me, but you know, just imagine me giving you the thumbs up. It's good. It's good. So that's all there is to it, guys. I'd like to make this more difficult, but I can't, so there it is. Now for this one, I want you to go ahead and try on your own, okay? 8x plus 3y equals negative 7. 7x plus 2y equals negative 3. You try it and then compare it to what I get. Okay, so hopefully you've got that done. I'm going to kind of walk you through how I would do it. I'm going to stick to using matrix A, so I'm going to use this clear button right here. And if I click that twice, it gets rid of everything. New matrix, 2 by 3, okay? And I want 8, 3, negative 7, and 7, 2, negative 3, okay? Everything's already set up for me, so I just plug that all in. There's my coefficient matrix, RREF of matrix A. There's my answer, okay? So your matrix should look like this, and your final answer should look like that. 1 comma negative 5. 1 comma negative 5. That's the ordered pair, the value that would make both of these true. Should you check your answers? Yes. It's very easy to type these in incorrectly, even with Desmos, so always plug your answers in. There will be times you'll get decimals possibly, so the whole, you know, oh, I got a decimal, I must be wrong. Not necessarily, so always go ahead and plug your answers in to make sure they're going to work. Okay, speaking of decimals, check out this monster. Now, this should scare you a little, but only because it's unfamiliar, right? 2.2x plus 3y equals 15.25. 4.6x plus 2.1 equals 18.325. It's a lot, but really it's just decimals. And with this matrix method, it's going to be pretty easy. The calculator is going to do it all for us. Only thing we need to be worried about is, are the x's stacked on top? Yes. Are the y's stacked on top of each other? Yes. Equals two constants? We're good. We're good. We don't have to worry about anything else, okay? If I click new matrix, now it gives me matrix B, doesn't matter. Make it a 2 by 3, start typing. 2.2, 3, 15.25, and 4.6, and 2.1, and 18.325. Okay, enter. There's matrix B. Should look like this. They match. Good. I've done it right so far. I think we're good. Now, our REF of matrix B this time, and you'll see it gives me 1, 0, 2.5, 0, 1, 3.25. Okay, all's good in the world. However, if you're like me, I can't remember. Yeah, I just wrote the answer here as a decimal, but I do oftentimes, usually like it as a fraction, there's the fraction button, 5 halves and 13 fourths. I just like that better. I think it's prettier, but it's up to you. Decimals, fractions, it's all the same number. Okay, it's all good. Now, couple more things before we wrap up here. I'm back. Before we wrap up, I want to show you these three. Here we have our basic enter matrix, right? 1, 0, 4, 0, 1, 0. And as long as we see this, 1, 0, 0, 1, that means we've got one solution and everything is as we would expect it, right? 1, 0, 4. 1x equals 4, 1y equals 0. So our solution would just be 4, 0. We're A-okay, everybody's happy. Here though, we've got something different, right? We have 1, 4, 0, but really what I'm really looking at is this 0, 0, 1 at the bottom, or really 0, 0, anything at the bottom. If it's 0, 0, 1 and not 0, 1 something, that tells me, what this is saying is 0 times y equals 1, which would be just 0 equals 1, which we know is not true. And if nothing's going to make it true, we say there's no solution. We have something very similar over here where we get 0, 0, 0. Now this tells me that 0 equals 0, which is always true. So this would be infinite solutions. We're not going to see this a ton with the matrix method, but it will show up occasionally. And usually, like the way that we'd find this with substitution or elimination or even graphing, it's totally different. So if we're using the matrix method, just like all the other methods, works all the time if you set it up right. So if you were to say, I'm going to always set it up for the matrix method, I'm always going to use the matrix method, that's fine. Mathematically, you can do that. However, you're going to hit some walls, and those two walls are going to be 0, 0, 1 at the bottom and 0, 0, 0 at the bottom. You have to be on the lookout for those, because if you only look at these last two spots where there's an answer, you're going to think, oh, I'm good, and then just move on. You have to be on the lookout for these bottom rows, okay? Always keep a good eye out. If it looks like this, you're good. Here's your answer, move on, you're all set. If it looks like this or this, be careful and make sure you select the correct one. All right, jot that down in your notes. Forward me any questions, and as always, thank you for watching. Good job today. Love you guys.